Good morning and welcome to all. Today we are going to have one more topic, which is very important to know about the information related transmission from source to the destination. So we are going for another important topic called as entropy coding. So we are already aware of what is meant by entropy. Entropy is nothing but the information which is conveying from source to the destination out of n number of symbols. What is the average amount of information that is being conveyed? Suppose, for example, if a source consists of 10 symbols, there is no guarantee that all the 10 symbols will communicate the same amount of information. So certain symbols doesn't convey any information, but ultimately we are going to calculate the average content of that is being conveyed from that particular source. That is called as an entropy. Then, if we are going for n number of informations and we are going to calculate individually what is the average amount of content that is being communicated. And suppose if we are going to calculate what is the chance of occurrence of that particular information. So we need to know exactly how the source is being communicated from input side to the output side. So basically in the input side, we are communicating the information, and the other end, at the destination, we need to know how much amount of information that was being calculated or communicated. That is will be known with another topic called as entropy coding. It is also simply called as a source coding. So two types of codings we are going to use in this source coding. In that, the first one is Shannon-Fallon coding and the one is Huffman coding. So these are the two different types of codings we are going to use in the entropy coding to denote or to calculate how much amount of information that is being conveyed from source to the destination with the respect to of how many bits it is being communicated. As of now, we have calculated whether the information in terms of probability. Now we are going to calculate how much amount of bits or how many amount of bits that it really required to carry our information from source to the destination. That will be calculated with two types of coding, that is Shannon-Fallon coding and Huffman coding. So basically, simply if you want to say that source coding is nothing but assigning of a binary data to our information content. As of now, we are not physically measuring the data. So here we are going to see how many number of bits that it requires to travel that particular information from source to the destination. So simply if you want to say entropy coding or source coding, it simply says that assigning of binary bits to each information symbol, or we can say that for each source symbol is called as a entropy coding or source coding. So that will be dealt with two types of codings. One is Shannon-Fallon coding and the one is Huffman coding. So first we will see the Shannon-Fallon coding. So as we all know that simply it's basically a simple and efficient technique. So for every algorithm there should be certain steps. So here also we are, if you want to know finally what is the symbol that is assigned for each source, it will be known in the this coding, and we have a certain algorithm. So this will be known in terms of while solving the problem itself. So let us have an example. So I'm going to take one example where we have six symbols. That is nothing but the source X has six symbols. Then the six symbols will have individual information content, and that will be assigned with a probability. So as I said that six symbols will have six symbols x1, x2 up to x6. Then each symbol will have a corresponding probability. That is chance of occurrence of this particular symbol. And the example, the source symbol 1 is having 0.3 probability, 0.25, 0.2, 0.12, 0.08, 0.05. So 6 source symbols is allocated with 6 different probabilities. Then we need to obtain how many number of bits that it will require to carry all the source 6 symbols from one point to the another point. So that will be known. So instead of first we need to know what is how many symbols we have, as we know that 6 symbols. So we will write the symbols xi as x1 to x6. Then we have given with a corresponding probability value also. We need to write the corresponding probabilities. And while assigning these probabilities, so we need to list the first step in this Shannon-Fallon coding is, first step is we need to list the probabilities in higher value to the lower value. That is nothing but descending order. So first probability always higher value, and the lowest value is a smaller value. So we are going to write in a decreasing order from a higher value to the lower value. Then we need to check the entire probability should be always 1. So therefore, what are the symbols we have given? It may be 6 symbols or 10 symbols. We need to know how many symbols are there and what is the total probability. No doubt, if you add all the probabilities, that it should be definitely should be 1. It should not be less than 1. Then So first step is we need to list the probabilities in descending order, that is from higher value to the lower value. So in this problem, the probabilities were in the same order, higher value to the lower value. So we have written the first step as writing the probabilities from higher value to the lower value. Then, so here the Shannon-Fano coding works on the procedure. It is nothing but it will divide and assign the probabilities. Okay, all the probabilities what we are having is 6, and here the partition is going to be used. Partition is nothing but dividing. So the entire probabilities, we have 6 symbols, and these 6 symbols have 6 different probabilities. We need to divide now these probabilities into nearly equally probabilities. Nearly equally probabilities, as we said that the total probability is 1, so the equally near probabilities will be exactly is 0.5 to 0.5. That is exact partition. So every time we may not this condition. So certain time we may get 0.55, and the second partition may be 0.45. That is the reason we are saying that the probabilities are partitioned or divided with equally nearer probabilities. So in this example, if you add these two, it is 0.55, and the rest of the probabilities are 0.45. So it is 0.55, and the remaining probabilities are 0.45. So certain cases if we get 0.6, 0.4 also. So luckily in this problem we are getting. So therefore the two sets first. One is 0.55 probability, and the one is, and then all the probabilities lies to 0.4. Then the third point is we need to assign 0 for higher probability value. Keep in mind, wherever we are having the higher probability value, we need to put 0, and lower all the probabilities. The next set, lower set should be all ones. Upper probability should be 0, and lower probabilities are all with 1. In this, we are having 2 probabilities in the upper set and 4 probabilities in the lower set. So there we are keeping upper probability 0, lower probability 1. And again, it should be continued. This partition should be continued until there will not be a further partition possible. And we need to assign the same rule, upper probability with zeros and lower probability with 1. If you do it continuously and until further partition is not possible, then the course coding ends, and then we can get a code like this. Okay, so if you see here, so we are having first probability 0, 0, and all the probabilities 1. Then if you see here, again the upper probability is having 2 values. So therefore again we need to divide this into 2 sets, and default upper set is 0, lower set is 1. So therefore, the upper set is not having further partition. Then we will move on to the next probability. As we said that the second set is having a total probability of 0.5. Then we will divide this into 0.2 and 0.25. Already we know that upper set is 0 and lower set is 1. Then it should be continued. So then afterwards, again we are having 0.25, that is divided into 0.12 and 0.13. So upper probability 0, lower probability 1. Then again we are having two more sets, that is 0.8 and 0.5, 0 and 1. Finally we are going to write the complete code of each symbol. Till now we know what is the symbol, what is the probability. With this code we are going to get what is the binary representation, what is the information representation of this particular source. That is nothing but source symbol 1 with 0.3 probability, the bits are 0, 0. Then the second one is 0, 1. Like that we have got the finally source bits. Here we have source symbols, source probability, and finally we got the information in terms of bits. Then we need to write the length of the each bit, or we can say that how many bits we have in the code word. So here we are going to write the length as how many bits we are having, 2 bits, then 2, second third bit also 2, then 3, then 4, and the last one is also 4. So we are going to get first the number of bits. So that is nothing but length of the bit, that is denoted with ni. Okay, then after that we need to again calculate how much efficiency that this technique works. So therefore we need to calculate the efficiency of this coding, because we are assigning the binary bits and finally we got the bits for the each source symbol. Then we need to know whether this technique is efficient or not, whether the bits whatever we are assigning are correct or not. For that we have to calculate the efficiency of this source code. The efficiency is calculated with entropy to the length of the code word. So entropy is nothing but, already we know that entropy will be calculated with information content into probability. Then h of x will be known. Then coming for length. This length is denoted as what is the length of each bit into probability. So that is nothing but we will calculate length is equal to summation of all the bits ni into pa. Okay, how many bits we have for first symbol and what is the probability. So like this, we will take the summation for all the symbols, we will get L. So therefore, we are going to calculate h of x and L. Then finally, we will get the efficiency. For this problem, the efficiency is 0.99. That much accuracy of the Shannon-Fano coding is approximately 0.99. If you multiply with 100, it is 99%. So in order to calculate the efficiency, what are the terms we require are entropy and length of the bits. Length of L will be calculated with summation I equal to 1 to m ni into p of I. Ni is nothing but bits for length of bit, or how many number of bits we had for each source symbol, and pi is nothing but probability of that particular symbol. And finally we can calculate the entropy. Thank you.